everybody. My name is Cordelia Dean, and we will be discussing AppArmor and HTTPS in this presentation. Hope you guys enjoy. So the contents of this presentation, we will be going over two main topics and then a subtopic. One will be AppArmor, having a light overview of AppArmor, going over its key features, use cases, AppArmor status commands, and hardening recommendations. And then another main topic that we will go over is HTTPS. We'll have a slight overview of HTTPS and learning about its key features. Then we will slide on over to IIS and learning about IIS key features and hardening recommendations for IIS. And then we'll take a look at Apache with Apache's key features and the hardening recommendations for Apache. And then the subtopic that we will also discuss will be HTTP versus HTTPS. AppArmor is a Linux security module that limits applications' capabilities through profiles, restricting access to files, networks, and system resources. It uses path-based access control, integrates with Ubuntu, and enhances security with a minimal performance impact, making it easy to manage. AppArmor key features. First, let's start with profile-based control. Applications are assigned profiles that specify their access to system resources. Profiles can be in two different modes. You have enforce, which actively blocks activities not defined in its profile, and complain, which logs policy violation without blocking them, which is useful for testing. Another key feature would be simplified rule definition. AppArmor uses human-readable text for creating security profiles. These profiles are easier to manage compared to the other security systems like SE Linux, making it more accessible for general users. Path-based access control. Unlike SE Linux, which uses labels for access control, AppArmor operates on the path of executables and resources, meaning permissions are granted based on file paths. Integration with Ubuntu. AppArmor is the default Mac solution in Ubuntu and is deeply integrated into its ecosystem. Many applications in Ubuntu come pre-built with AppArmor profiles, such as web browsers, DNS servers, and databases. Low overhead. AppArmor imposes minimal performance overhead on applications, making it efficient to run without significantly impacting system resources. AppArmor use cases. Web servers. Restricting web server access to specific directories and limiting network connections can prevent attacks like file inclusion and unauthorized modifications. Containers. In containerization environments, AppArmor profiles can help further secure applications running within containers, limiting their interaction with the host system. Desktop applications. Protecting everyday applications like browsers and email clients from accessing sensitive system files. The purpose of checking AppArmor status is to view the number of active profiles and to gather a summary of the AppArmor profiles. The command you can use for this is sudo AppArmor _ status. We will now go over the 3 hardening recommendations for AppArmor. And below I have the commands listed which you can implement in order to activate these hardening recommendations. First, enabling enforcing mode for critical applications. ensuring that essential servers like web servers, databases, and SSH run under strict AppArmor profiles in enforcing mode to prevent unauthorized access and actions. Secondly, regularly update and audit profiles. Keeping AppArmor profiles up to date with the latest application version and regularly auditing them to identify and rectify any unnecessary permissions. Use complaint mode for testing. Before enforcing new or modified profiles, run them in complaint mode to log potential violations without restricting operations. This helps in fine-tuning profiles without disrupting services. Now that we're done with AppArmor, let's get on to HTTPS, also known as Hypertext Transfer Protocol Secure. Let's go over the HTTPS overview. HTTPS, also known as Hypertext Transfer Protocol Secure, is an encrypted version of HTTP used for secure communication over the Internet. It combines HTTP with SSL and TLS encryption to protect data transmitted between a user's browser and a website, ensuring confidentiality, integrity, and authentication. HTTPS key features. First, encryption. HTTPS encrypts data using SSL or TLS protocols, ensuring that sensitive information such as your passwords or your credit card details are protected from eavesdroppers and man-in-the-middle attacks. Data integrity. HTTPS verifies the data hasn't been altered or corrupted during transmission, preventing tampering. Authentication. Through SSL and TLS certificates, HTTPS ensures that websites being accessed is legitimate, helping users to avoid fraudulent sites. SEO and trust. Browsers often display a padlock symbol to indicate a secure connection, and search engines like Google prioritize HTTPS-enabled websites in search rankings. IIS, also known as Internet Information Services, is a flexible, secure, and manageable web server created by Microsoft for hosting websites and web applications on Windows servers. It supports HTTP, HTTPS, FTP, and many more, enabling users to deliver content over the Internet or Intranet. Now let's go over the IIS key features. Scalability. IIS can host a single site or scale to handle thousands of sites on one server, making it suitable for both small and large enterprises. Security features. It provides robust security options such as authentication, authorization, SSL and TLS encryption, request filtering, and the ability to isolate applications to improve security. Management tools. IIS includes user-friendly management tools such as IIS Manager, which provides a graphical interface for configuring and monitoring web servers. Hardening recommendations for IIS. Enable and enforce HTTPS. HTTPS ensures secure communication between users and the server by encrypting data and preventing man-in-the-middle attacks. To do this, you must install SSL and TLS certificates and configure IIS to require HTTPS for all websites, redirecting HTTP traffic to HTTPS. This can be done by setting up URL rewrite rules for enforcing HTTP strict transport security. Disable unnecessary features and modules. Minimizing the attack surface by disabling unused modules reduces the potential vulnerabilities that could be exploited. In IIS Manager, you can go to the Modules section and disable any unneeded modules based on your service requirements. This limits exposure to attacks on those features. Enable request filtering. Request filtering blocks potentially dangerous requests that may include malicious content such as large payloads and suspicious URL patterns. To configure request filtering in IIS, to restrict file types, extensions, or HTTP verbs that are not required. For example, block executable files from being served or executed from the web server. Apache is an open source, cross-platform web server developed and maintained by the Apache Software Foundation. This is one of the most widely used web servers globally, known for its flexibility, performance, and extensive customization options. Now let's discuss some of the key features of Apache. Cross-platform support. Apache runs on multiple platforms including Windows, Linux, and macOS, making it highly versatile. Modular architecture. Apache uses a modular design, allowing users to load only the features they need through modules to enhance performance and security. Open source and extensible. Being open source, Apache has a large community of developers contributing to its continuous improvement. It also integrates easily with languages like PHP, Python, and Ruby for serving dynamic web applications. Now let's discuss the hardening recommendations for Apache. Let's first start with restrict directory and file access. Limiting access to sensitive directories and files reduces the risk of unauthorized access or information leakage. This can be done by using Apache's allow, deny, and require directives to restrict access to certain directories. Secondly, configure security headers. Security headers protect against various web-based attacks such as cross-site scripting, clickjacking, and other code injection threats. Two of the security headers that I found that you can configure are listed below. Lastly, limit request size and timeouts. Restricting request size and setting appropriate timeouts to help mitigate denial of service attacks and other resource exhaustion exploits. This can be done by setting the below configurations as you see. Now, let's discuss the difference between HTTP and HTTPS. HTTP enables the transfer of data over the web but lacks security as it transmits data in plain text, making it vulnerable to interception. This is suitable for non-sensitive exchanges, but poses a risk for personal or financial data. HTTPS addresses these concerns by using encryption through SSL and TLS, providing confidentiality, data integrity, and authentication. This ensures that information sent between users and websites are secure from tampering or eavesdropping. Today, HTTPS is the standard for websites handling sensitive data, offering a safer and more trusted browsing experience. We have now come to the end of our presentation. Thank you for watching.